All right, so in this video, we're going to take a look at a few examples regarding the equations of tangent lines. And so the first example will be to find the equation of a tangent line at x equals 2 of the given function. Real quick, just maybe as more of a review at this point, we're told to find the equation of a tangent line. So the equation of a line. And if it's been a while, equation of a line, you always need two things. You always need a point, and you always need a slope. If you have those things, then you can go to the point-slope form of a line. And so, again, it's going to be important for us to identify a point and a slope. The point is going to be pretty easy to find because we're given x equals 2. So when I take x equals 2 and I plug it in, my f of 2, when I plug that in, that spits out a negative 5. So there's my point. Now, for the slope, that's where we're going to have to go and study the slope predictor that we talked about in the last video. So that slope of the tangent line, that's going to give us a formula, which is essentially a formula that gives us the slope of every single tangent line to every single point on the curve. So let's go ahead and start with that. M tan, slope of the tangent line, is going to be the limit as h approaches 0 of now our difference quotient. So we've got 5 minus 3 times x plus h minus x plus h squared minus the entire function of 5 minus 3x minus x squared. And that whole thing is over h. So now, again, we're going to simplify this down just like we would have for a normal difference quotient, but it is very important to carry this limit notation down every single step along the way. That's something that's incredibly important and something I will be looking for as I grade your papers. So every time you see you need the limit all the way through until we get to the end, and I'll point that out. So here, I'm going to go ahead and I'm going to distribute the negative 3. This negative 3 here, I'm also going to distribute the x plus h squared as well as the negative, and this negative as well. So I'm going to have a big long list of things on top. So I've got 5 minus 3x minus 3h minus x squared minus 2xh minus h squared minus 5 plus 3x plus x squared, and that whole thing is over h. Now, you've done enough of these to know that if you've done this correctly, everything in the numerator without an h should go away. So notice the 5 and the negative 5. We've got the negative 3x, we've got the positive 3x, the negative x squared, and the positive x squared. And if everything without an h in the numerator went away, that means that everything we have left has an h in it. So once again, carrying down this limit notation, limit as h goes to 0, I can factor this h out. I get a negative 3 minus 2x minus h all over h. This h in our denominator, which was always the problem, is now able to be divided off with the h in the numerator. And now for my last step here. When I now have everything simplified down, I'm going to take my h going to 0, and every place I see an h, plug in a 0. So then this guy right here goes off to 0, and it leaves us now with our m tan of negative 3 minus 2x. And remember, I called that a slope predictor. That's going to give us the slope of all tangent lines to this curve right here. Now, for us, we don't want all of them. We want the one in particular at x equals 2. So what I'll do now is I'll take this slope predictor, I'll evaluate it at x equals 2, and when I plug that in, that's going to give me a negative 7. And so using this information here as my point, this information here as my slope, I can now go into the point-slope form of a line and simplify it down. So that would give us y minus a minus 5 equals a negative 7 times x minus 2. And when we simplify this down, we get y equals negative 7x plus 9 as our final answer. So this line would be tangent to this curve at this point. All right, so we'll take a look at another example, and we'll use the previous function as well. So we're going to find the equation of the normal line to the curve at the same x equals 2 point. Normal just means perpendicular. And so we know that from the last example, the slope of the tangent line ended up equaling -7. So in this case, the slope of the normal line is going to be the opposite reciprocal, so positive 1/7. So we're still using the same point, but now we have a different slope of positive 1/7. So if I take that, I get y minus a minus 5 equals a 1/7 x minus 2. And when we simplify that, we get a 1/7 x minus 37 over 7. So the effect of a problem like this isn't as much doing it as now seeing the result. So what I would encourage you to do is go to Desmos.com. That's a really nice and easy to use graphing calculator on your computer. Go to Desmos.com, plot the original parabola, the 5 minus 3x minus x squared, plot the tangent line, and also plot the normal line. I think it's going to really help you better understand what we found by seeing all of those together. And you can see finding it is not very difficult. Just a little bit of algebra there, and then evaluated h goes to 0. But I think if you see it and understand what you found, you'll really gain a better appreciation for it, and hopefully be able to apply it in future ways down the road.